Hello friends, welcome to my channel. First wish you a very happy Diwali. This video is useful for RINL MT examination and ISRO, upcoming ISRO and both ISRO scientist and ISRO technical assistant, and for SSC JEE also. This is part 2 of this series. Question is, assertion: forging dies are provided with taper or draft angles on vertical surfaces region R if it facilitates complete filling of die cavity and favorable grain flow. So first one, forging dies are provided with taper and draft angles. This is true. It facilitates complete filling. No, it's false. So A is true, H is false, R is false, C is our answer. In open die forging, a disc of diameter 200 mm and height 600 mm is compressed without any barreling effect. The final diameter of the disc is 400 mm. The toe strain is how much? So toe strain we have to calculate. In GATE also, see 2007 question. In ISRO also they are asking this type of question. That time they won't provide you calculator. ln initial area divided by final area. This is the formula for true strain, or you can write it as initial area is pi by 4 do square divided by ln pi by 4 final diameter square. So it's 2 into ln pi by 4 pi by 4. This is pi by 4. Cancel do by df. So 2 into ln initial diameter or original diameter, it's 200 divided by final diameter is 400. So 1 by 2, it's minus 0.69. 2 into 0.69, you multiply, you will get your answer. You will get minus 1.386. So from option C is our answer. You have to remember ln2 value. It's 0.69. In ISRO they won't give you calculator, but GATE you can calculate this one. List 1 and list 2 matching. Riveted joints, it's fullering A with 3. So from option you can cut. C you can cut and B you can cut. Then welded joint, knuckle joint, angular movement, D with 2. For welded joint, fusion also available, B with 4. So B 4, then C, leaf spring is nipping. So 3, 4, 1, 2. D is our answer. Forging method for reducing the diameter of a bar in the process making it longer. It's fullering process. Offsetting is opposite. It will increase the diameter of the bar. Consider the following steps involved in hammer forging a connecting rod from a bar stroke. So from a bar stroke you will make a connecting rod. And we know final is trimming. Trimming is final. So if you start from opposite side, 2 should be final. So B is your answer. You can cut A, C and D. You can check this one also. Before trimming you have to do finishing. It's 3, correct. Then blocking is semi-finished operation. This is also correct. Then 4 is fullering. Then 5 is edging. Yes, this is correct. First fullering, then edging, then blocking. Blocking is semi-finishing operation, then finishing, then finally trimming. This one already I told. Operations involved in forging from bar stroke to connecting rod. First is fullering, then edging, then bending. Bending in this question not available, so cut this one. This one also cut, this one also cut. Then blocking, already discussed. Blocking is semi-finished operation, then finishing, then trimming. Same question asked in SSC. In the forging operation, fullering is done to draw out the material. Consider the following operation involved in forging a hexagonal bolt from a round bar stock whose diameter is equal to bolt diameter. So, hexagonal bolt from round bar stock. First we will do flattering, then offsetting, then swagging. Cambering is last. So, from option 1, 2, 3, 4, A is our answer. In drop forging, forging is done by dropping the workpiece at high velocity, hammer at high velocity, the die with hammer at high velocity. C is our answer. Drop forging is used to produce, small components only we are using for making of small components only. Least 1 and least 2 matching. Investment casting, it's turbine blade. Then die casting, for die casting, carburetor body, B with 6. Then C, centrifugal casting, hollow cylindrical. So, cast iron pipes, it's 5. Then D, drop forging, connecting rod, yes, connecting rod available, 3. Then extrusion, GI pipe, galvanized iron pipe, 4. Cell molding, turbine rotors, 1. E with 4, F with 1. Nowadays in every examination they are asking this type of question, least 1 and least 2 matching. So these examples are very important. Question is, the forging defect due to hindrance to smooth flow of metal in the component called lap occurs because, answer is, the corner radius provided too small. B is our answer. Which one of the following is the correct statement? So, extrusion used for manufacturing of seamless tubes. No. Extrusion is used for reducing the diameter of round bars and tubes by rotating die which open and closest rapidly. No. Reducing diameter of round bars, we are using rotary forging, or we can call it as swagging operation. Extrusion is used to improve fatigue resistance of the metal by setting up compressive stresses on its surface. No. Short pinning we are doing for. Extrusion comprises pressing the metal inside a chamber to force it out by high pressure through an orifice which is shaped to provide the desired form. It should be form of the finished product. D is our answer. This question is very important for SSC JEE and PSU. The extrusion process used for the production of toothpaste is impact extrusion, 3. So from option D is our answer. Metal extrusion process is generally used for producing uniform solid section. No, we can produce hollow sections also. Uniform hollow sections, solid section also we can produce. Uniform solid and hollow section, C is our answer. Varying solid and hollow section, no, this is the drawback of extrusion process. Least 1 and least 2, already I told. Connecting rod, these examples are very important for all exam. Connecting rod, it's forging, so A with 3, you can cut B and D. Then pressure vessels, it's collapsible tool, it's extrusion, D with 2, so A is our answer. You can verify this one, A with 3, B with 1 pressure vessel, it's correct. For boiler application, we are using welding for making of boiler tube. For joining of boiler tubes or making of coils, we are doing welding operation. So B with 1 is correct. Machine tool beds, C with 4, casting, it's correct. Then D to collapsible tube. So A is our answer. What does hydrostatic pressure in extrusion process improve? Hydrostatic extrusion, it improves ductility. Which one of the following processes is the wire drawing process? Wire drawing, it's tensile load. B is our answer. For compressive, it's coining. In coining process, we are using compressive shear. This is for punching and blanking operation, we are using shear. List 1 and list 2, wire drawing already discussed. A should be with tensile force. Then extrusion, blanking with shear, extrusion, compressive force, bending, spring back. Wire drawing, A with 2. So you can cut A and D. Then extrusion, it's compressive force, B with 3. B with 3. Then C, blanking with shear, C with 3. So you can cut B. C is our answer. Bending, spring back. C is our answer. Match list 1 with list 2. So A, malleability, it's for rolling. So 3. Then hardness, impact or indentation or scratch. B, 4. Then resilience, it's impact load. C, it's 2. Isotropy, direction dependent. So it's 5. 3, 4, 2, 5. A wire of 0.1 mm diameter is drawn from a rod of 15 mm diameter. Dies giving reduction 20%, 40% and 80% are available. For minimum error in the final set, the number of stages and reduction at each stage respectively would be how much? So minimum error we have to calculate. So from options we will start. For A, 3 stages with 80% reduction in all stages. So final diameter we will get df equal to initial diameter is 15 mm, 15 into 80% reduction in all 3 stages. So 1 minus 0.8 into 1 minus 0.8, 3 times 1 minus 0.8. If you calculate this one, you will get 0.12. So what final diameter given? It's 0. This is actual. So error for case A, 0.12 minus 0.02. So for B also again we have to check. 4 stages, 80% reduction. First 3 stages followed by a finishing stage of 20% reduction. So first 3 stages, 80% reduction, last is 20% reduction. So df 15 into 1 minus 0.8, 3 times 1 minus 0.8, again 1 minus 0.8, then 40% reduction, last case, multiply 0.4. So if you calculate this one, you will get, this is 20% reduction. So multiply 0.2, you will get 0.096 mm. So error is 1 minus 0.1 minus 0.096. You will get 0.004. And for C, 5 stages and reduction in 80%, then 40%, then 20. So df is 15 into 80% 2 times, so 0.8 into 1 minus 0.8, Then third one 40%, 1 minus 0.5, it's 2 times 1 minus 0.5. Then last is 1 minus 0.2, 20% reduction. So if you calculate this one, you will get 0.1728 mm. So error is 0.1728 minus 0.0728 mm. So minimum error we have to calculate. For minimum error, case B is minimum error. So B is our answer. Rod and tube drawing. A moving material is used in, it's for tube drawing. For boiler tubes, we are manufacturing. For boiler tubes manufacturing, we are using this process. In ISNT, Indian seamless metal tubes, and Jindal also, they are producing this type of tubes by using this method. POSCO also producing in Korea. Then your Tenaris, they are using this process. Best position of crank for blanking operation in a mechanical press is top dead center, no, 20 degree below top dead center. B is our answer. So question is, a blank of 30 mm diameter is to be produced out of 10 mm thick sheet on a simple die. If 6% clearance is recommended, then the nominal diameter of this is die and punch are respectively. So die and punch. First we have to check operation. Which operation we have to do? It's a blank of 30 mm diameter we have to produce. So it's blanking operation. So blank dia given its 30 mm operation is blanking operation. Hole is requirement here. No, that disc is requirement. So it's blanking operation. If hole is the requirement, then operation is punching operation. So for blanking operation, shear should be on die, and for punching operation, shear should be at punch. And for blanking operation, clearance should be in punch. And for punching operation, clearance will be in blank, should be in die. So this is blanking operation, clearance should be here in punch. It's blanking operation, clearance should be in punch. So diameter of die and punch we have to calculate. Nominal dia of die is, dia is, it's 30 mm. Then punch dia is dia minus 2 times of clearance. Clearance is 6% of thickness is 10 mm. So 30 minus 2 into 6% of 10 mm. Then you will get 0.6 or multiply 1.2. 30 minus 1.2, you will get 28.8. So from option D is our answer. In blanking operation, the clearance provided on, already discussed, in blanking, clearance should be on punch. And for die, the operation clearance, if clearance on die, operation should be punching operation. This is very, very important for all exams. Question is, in a blanking operation to produce steel washer, the maximum punch load is used 2 into 10 to the power 5 Newton. The plate thickness is 4 mm and percentage of penetration is it's 25. The work done during this curing operation is how much? So work done we have to calculate. Blanking operation, force is punch load used, F is 2 into 10 to the power 5 Newton. Then thickness is 4 mm. Then percentage of penetration it's 25%. Work done we have to calculate. So work done formula is force into penetration into thickness, 2 into 10 to the power 5. Then penetration is 25%, 25 by 100, thickness is 4. So you will get 10 to the power 3. Then this is in mm, so divided by 10 to the power 3, it's 200 joule. A is our answer. This is the end of part 2. Next question onwards I will solve in part 3. Around 200 to 300 questions I will solve. So in upcoming RINL MT examination, minimum 10 questions you will get from the 300 questions. So these questions are very important for all examinations. Thank you friends. Thank you for watching my video. Thank you.